Hey everybody, the Dutch Viking here. I'm going to be showing you how to build a Voodoo Quads 210 FPV racer. I'm really excited about this frame and this build, and I'm going to be showing you a lot of the tips that I've picked up from other great pilots and hopefully implementing them to build something pretty neat and hopefully things that will inspire you to build your own. So let's get started. First off, I've unboxed the frame sent to me from Voodoo Quads Direct out of Florida. Love those guys. In that you're going to find a lot of really cool components from their standoffs and nylon nuts as well as their screws. And then you get the frame itself. Now you've already noticed I've taken a Sharpie oil marker and I've gone around the perimeter. But typically I'll do one entire second coat. Just makes it look clean and good. The next thing I'm going to do is start a test fit of most of the major components that I have. This helps me make sure that everything is the right length and everything's going to line up perfectly and I didn't make a mistake in some of my ordering. So first I'm going to mount the motors. These are Cobras, 2204s, 2300 kV. Big shout out to RotorGeeks.com. The Cobras can be pretty hard to get a hold of, so I'm really appreciative of everybody at Rotor Geeks for stocking them, supplying them. If you can, they're a fantastic high-end motor. You'll also notice that I've started to dress this one with some nylon mesh, and it's 1/4 inch purple from wirecare.com. In order to dress these with the nylon mesh, first I have to work tips gently into the nylon. Try to put uniform pressure straight into the sleeve. Working them up around the solder connection from the factory can be a little funny, but eventually you can seat it right up close to the motor. We'll finish that later on with some heat shrink. As I lay the motor on its motor mount position, I can kind of see how long the leads are. On this smaller 210 frame, the leads right off the motor are plenty long to get past where the power distribution board is going to be. So I have lots of length. I just use the entire length as I need right now, and then I finish by trimming with some scissors. Careful not to cut the leads themselves. I'll go back later on and actually make a much finer and more precise cut on the mesh as we start to look at soldering. Now the Cobra motors all come with two different kinds of screws to fasten it onto the frame, the hex head and the Phillips head. Now since Voodoo Quads uses hex head, I'm going to stick with hex. That way I only need one tool to take this thing apart when I need to fix something. The next step in my test fit is going to be to make sure that all of the wires that run between my PDB, my ESCs, and my motors are all the right lengths. For me, I like to economize space on a build this small. It's also important for me because I believe that cleanliness on a build like this means I can access things faster, which means I can repair them more quickly, which means I'll be flying faster after a crash. For ESCs, I'm using 20 amp LittleBees. These ones are put out by ReadyToFly.com. I've only heard really great things about these, very slim, low profile, and should fit well in this Voodoo Quads 210. Next up, the real assembly begins. I'm going to start by taking the PDB power distribution board and soldering to that all 4 ESCs, as well as the XT60 power plug and my 5-volt step down, which in this case, Voodoo Quads has provided a wire and chip rather than just a solid state chip. This allows me a little bit more flexibility on where I mount it and being able to tuck it away into the finished quad. Pretty cool. You'll also notice that I'm going to be hiding my front 2 ESCs underneath the power distribution board. On this Voodoo Quads 210, that gives me a little bit more space to work with, and it's kind of a nice cheat when you need economy of space. I always like to use a little bit of solder flux to prepare the pads for soldering. The whole concept with the power distribution board is that the LiPo battery is sending its voltage into the power distribution board, and then the board is simply distributing the power to our ESCs following the red or hot positive lead and its ground, black. Those ESCs are taking its power from the battery and then delivering that to the motors in whatever capacity the flight controller tells it to. Thus why we have the signal wire. Our flight controller and our receiver also need to get power from the PDB, so we use a 5-volt step-down regulator that reduces the power from the LiPo battery what I've done is I've actually pre-envisioned where this ESC is going to lay under the power distribution board, and I've wired up through the space between the back left ESC's positive and negative lead, the underbelly's ESC's signal wire and ground, as well as the power, which are going to lay right here, and I will trim them accordingly. Before I add my 5-volt step down, I want to take a look at what I've created so far, and this is pretty much the finished power distribution and ESC setup. Which you can see I have the 2 forward ESCs laying on the back of the power distribution board, which we will stand off from the frame, and the aft 2 ESCs, which will be responsible for powering the back 2 motors. So that whole little setup will sit right in the frame. Next, I'm going to be focused on connecting the output of the ESCs to the input of the motors. Then I take my Sharpie oil marker and I make some little tick marks right along the wires where they're going to intersect. Now I've cut all the wires coming out of the ESCs, measured them correctly to the wires coming out of the motors, and I've tinned them using a little bit of flux, preparing them for solder. I'll prep these lines, covering them both with heat shrink as well as the finishing nylon weave.
taking it back so fast?
Because I don't want much heat. If I put too much heat on, I'll melt the purple.
You don't want to do that?
I don't want to do that.
Now that sounds good.
Now Now I've decided to replace the standard nylon screws and nuts that come stock with the Voodoo Quads 210 with one of my 180 piece kits of nylon 3M hardware that can safely be used on the stack of the flight controller and the power distribution board. This is just so that I can have a little more stable construction and spacing, especially with those two forward ESCs tucked underneath of the power distribution board. Now, there are a lot of great tutorials already out there on exactly how to solder your Naze32. For now, I have chosen to mount the pins for my servo outs facing in. You'll also notice that I've created a slight upward bend using a pair of pliers and a small flathead screwdriver to create the angle needed for the plugs to clear the main processor. I like to solder as flush as possible, so instead of angling the actual pin set, I've angled the final point pins, and that can be done very gently and still accomplish the same goal. Similarly, in order to conserve space, I'm going to be mounting my auxiliary outputs also upward and inward using the 90-degree pin set. You'll notice now that I have my 5-volt step down from Voodoo Quads coming off of the PDB and up around the front of the flight controller to connect to the last set of servo pins, respecting the positive and ground as illustrated on the diagram for the Naze32. Additionally, I have the leads ready for the receiver and plugged into their respective places on the Naze32. This is my Fly Sky 32 channel 2.4 gigahertz receiver, which will be tucked up underneath the top plate. I'll show you in just a minute. And as such, all of the leads for that receiver are plugged into the Naze32 flight controller. This is my first ESC for motor number 1. I have to make sure to follow the proper designations of my signal wire, which is white, and my ground, which is black. On the Naze32, you'll see the key map located just outside the bounding box of the servo pins. From inside to outside, we have the signal wire, positive, and ground. In this case, I'll make sure that my ground black is on the bottom and my signal wire is on the top, and plug it into servo position 1. I'll repeat these steps with motors 2, 3, and 4. That's what it looks like with the 4 ESC signal and ground wires properly plugged into the pins, as well as the power that will power the flight controller and the receiver. Now I'll take some time to dress up these wires and make them look nice. I'll go ahead and put my nylon nuts back onto the stack to make sure everything is secure now. Now in this case, I've chosen to go with the Eachine combo pack. This combo pack includes the video transmitter as well as a CCD camera. I prefer CCD cameras over CMOS because they do not have the rolling shutter effect. If you're familiar with photography and video, you'll know what that means. Now this is a very powerful little video transmitter. It has over 600 milliwatts of power. That's a lot of good clean signal. It also comes with a power cord and signal cord combo, and the antenna, which will be replaced by an IB Crazy Clover. Before I actually attach my video transmitter, I just want to make sure that I have the power coming off the power distribution board properly, that way I can button up everything there. To do so, I'm going to take the included power cable and snip off the top, exposing just the positive and ground leads, and that will go directly to the power board because this video transmitter can handle a lot of power. Following the diagram in the instruction manual, we can see that the main bus harness for the video transmitter has 2 sides. One is the side with the yellow that goes down to the harness for the camera itself. And on the other side, we actually have the power leads, which go to this giant plug, which will happily snap off. Death to the giant plug! So I'm going to previs the placement of my video transmitter by first plugging in the attached harness. That's roughly where I want my video transmitter. I can get away with that much distance because I'm going to be using this antenna extension. I like these because when a crash happens, the force of the crash is taken out on the antenna extension and not on the video transmitter itself. Since these leads are too small for a standard pair of wire cutters and strippers to do any work on, I just use my fingernails. Now I can go ahead and button up my stack. Now this FlySky receiver that I'm using only has 6 channels. For that purpose, I'm going to look at taking off one of the extra leads on this wiring harness. Ground, hot, and signal wire, followed by channel 1, 2, 3, 4, 5, 6. Number 7 right here, I don't need. It's just a waste of space. I'm going to take a little screwdriver and simply pop out this 7th lead. Simply slide it into the receiver mount. These will be dressed back over the flight controller stack, plugged into my receiver, and the receiver will be attached to the bottom of my top plate, like so. When plugging in my battery lead, I simply want to follow the diagram, which shows clearly signal, hot, ground. Signal, hot, ground. Which again, following the schematic, is going to be signal. Finished look of the receiver. Now I'm going to be placing my receiver as well as my video transmitter directly underneath the top plate of the frame. So positioning it here just to make room for the antenna as well as the power cord. It will be canted slightly to port, and in the front bow of the airframe we will have our video transmitter. I'll be using some Scotch 20-pound red double-sided stick tape to make sure that these guys stay in place. Now because I don't like red stick tape exposed on an open area of the frame, what I'll actually do is start by pre-envisioning this receiver in the aft here, and then just using a little pen to draw the outline of the frame. That way I know exactly where I shouldn't be placing red stick tape. I'm going to do the same thing with the video transmitter now. So back there a second ago, I was looking at this layout and I realized I really didn't like the receiver leads coming and laying across the top of this flight controller. I don't know what I was thinking. So I've decided to actually pick up the flight controller, rotate it 90 degrees so that the servo leads are now protruding from the aft. This also means I'm going to run the ESC leads from the flight controller on top, around the front side, and underneath to the bottom. Additionally, I'm going to take the 5-volt step down and run it to the aft and bring it up around to plug in to its respective space. This is a great example of working on the fly and realizing you did something you didn't like. It's also worth noting that since the video transmitter antenna is going to be now conflicting with the space occupied by the new position of the ESC leads, I actually just ripped off the pin set for the auxiliaries, as I'm not going to be using them. Now we have something that looks a lot cleaner on the inside. You'll notice that as I close up the lid, the leads for the receiver just coil nicely right in the aft of the airframe. And now I have a lot more room for the ESC lines as well as the video transmitter. Hey gang, this is just an update to this build video as the original footage was filmed a few months ago. Since then, a lot of you on social media have seen the frame skirt that I have, which was designed by Armor Flight and Nick Nito. You can see up close what that looks like. A lot of nice grass stains, kind of cool. This frame also took a fatal blow recently to its port arm, which is pretty disturbing. I know, sorry, should have given you a fair warning, pretty graphic. It is being replaced by Voodoo frames with their 4mm, so pretty stoked about that. Again, incredible people to work with. Big shout out to Dennis, thank you so much. The other thing that the skirt does is help to secure the camera in place. I love skirts for that reason. Planes have fuselages for a reason, cars have bodies for a reason, and quads should have protection too. The other thing that the skirt does is it allows the camera to stay properly mounted, tightly in place. I love that feature of this. I didn't go over that in the original build video. A lot of guys use hot glue. Sometimes we'll actually use electrical tape against the stanchions and standoffs that hold the camera in place with the particular quad design that we're dealing with. But in this case, the skirt does all the heavy lifting for me. That thing is solid in there and I'm able to tweak the angle on the fly. No pun intended. I highly recommend that you work with somebody to design one and have it printed 3D. The other things that I really didn't cover in the original footage are simple things like weaving the battery strap through the top plate as well as putting on the Velcro strip for the batteries. Again, I like to have the soft side down on top of the plate and doing the bristle side on the batteries themselves. The only other modification I made was adding the GoPro mount from Voodoo Quads, and these are two little aluminum holders that screw into the top plate pretty easily. I didn't really explain XT60 either. That's something you can research on, and right now, believe it or not, we're all kind of moving towards XT30, which is even smaller, easier to work with on these smaller builds. So check those components out. Thanks again for watching the build video, and I hope you have a great time building and flying your own quads and racing them. Any questions, feel free to ask on my blog or here on YouTube in the comments section. I'll do my best to answer or point in the right direction. Thanks again. Bye.